Hello everyone. In this project, I developed a credit default classification model and evaluated it using responsible AI principles. The goal was not only to build a predictive model, but also to ensure that the model is interpretable, fair, and ethically responsible. To achieve this, I compared several models, applied explainable AI techniques using SHARP, and evaluated fairness and ethical implications of the predictions. First, I prepared the dataset by cleaning missing values, separating numerical and categorical features, and applying pre-processing through a machine learning pipeline. I trained three different models to compare predictive performance and model behavior: logistic regression, random forest, XGBoost. Among this model, logistic regression achieved the highest validation ROC of approximately 0.683, slightly outperforming XGBoost, but however, I use XGBoost for explainability analysis because tree-based model work particularly well with SHARP and allow richer interpretation of feature effects. To evaluate the reliability of the model, I calculate several performance metrics including accuracy, precision, recall, FE score, ROC-UG, because the dataset is higher imbalanced with relatively few default cases. ROC-UG is an important metric for evaluating model discrimination ability. Although accuracy is relatively high, recall is lower, which reflects the difficulty of detecting default cases in imbalanced credit dataset. I used SHARP explainability techniques to increase interpretability. I started by analyzing the global feature importance using the SHARP summary display. The findings indicate that the most significant factors influencing default risk forex are financial variables and external credit scores. In general, higher credit score lower the likelihood of a default. Financial factors like loan and annuity amount also have a significant impact, suggesting that risk evaluation is heavily influenced by financial capacity and repayment load. I then explained the predictions for a specific application used a SHARP waterfall plot. Each feature's contribution to risk or lowering the anticipated default risk for a particular situation. To is demonstrated in this local explanation. To assess fairness, I analyzed the potential gender bias in the model. I compared the average predicted default probability across gender group. The simple demographic comparison provides an initial fairness check similar to demographic parity analysis. The model predicts an average default probability of approximately 50.9% for male applicants and 30.2% for female applicants. This indicates a slight difference in predicted risk between the two groups. However, the simple comparison alone does not necessarily indicate discrimination. The difference may reflect on the underlying financial patterns present in the dataset. Nevertheless, fairness monitoring is important, and demographic attributes should be evaluated carefully to ensure that automated systems remain fair and compliant with regulatory standard. Automated credit risk models have significant real-world implications. False positives, where a model predicts default but the applicant would actually repay, mean unfairly denying individuals access to credit. False negatives were the most where the model predicts repayment but the applicant defaults can expose leaders to financial losses. In additional demographic attributes such as gender or age may introduce intended bias. Therefore, predictive models should be regularly audited for fairness and transparency, and they should support human decision making rather than fully replace it. Explainable AI techniques such as SHARP help improve the transparency by allowing analysts and the regulators to understand the main factor influencing model predictions. In conclusion, this project demonstrates as responsible AI workflow for credit risk modeling. Logistic regression achieved the best predictive performance, while XGBoost was used for detailed explainability analysis. SHARP analysis identified key financial and credit-related features driving default risk. Fairness analysis and ethical reflection further ensure that the modeling process aligns with responsible AI principles. Overall, combining predictive modeling with explainability, fairness evaluation, and ethical reflection helps build more trustworthy AI system for financial decision making. Thank you.